We are going to continue section 7.2, which is hypothesis testing for population mean when population standard deviation is known. I mentioned at some point earlier that there are two methods for doing this hypothesis testing. In the last video, we talked about the p-value method, and in this video, we're going to talk about the rejection region method. Now, this one I personally prefer. What you do with a rejection region is you're still going to have like a left-tailed test, a right-tailed test, and a two-tailed test. So we'll get those on there. And this is going to be a negative z-score. This is going to be, we're going to shade to the left. This is going to be a positive z-score. We're going to shade to the right. And then on our two-tailed test, we're going to have two sections, and we're going to have a negative z-score here and a positive z-score here. But what's different about these rejection region methods is that we're going to use alpha. We're going to use alpha to look up the area and then figure out the z-score. So again, this area is alpha, which makes each of these areas 1/2 alpha. Remember that alpha was our level of significance. So then we make our little rejection region, we look up alpha, figure out this z-score, and then we're going to place our test statistic on that same standard normal curve. And if the test statistic falls in the shaded region, which is called the rejection region, then we reject H sub 0. So if the test statistic falls in the rejection region, that's the shaded region, we reject H sub 0. If it does not, then we fail to reject H sub 0. So, okay, to help me remember this, the way that I think of it is like if my test statistic would fall right here, then it's in the shaded region and it's the reject H sub 0. So I just kind of think in my head, reject the shady hoe. I know that's not really appropriate, but that's how I remember it, so do with that what you will. We're going to do a couple of examples so we can practice seeing if we would reject H sub 0 or fail to reject H sub 0. I don't remember what page these are from. I could figure it out probably. Looks like page 374. And we're going to do 19, 20, and 21. In exercises 19 through 24, find the critical values and the rejection regions for the type of z-test with the level of significance alpha. Include a graph with your answer. So, 19. We have a left-tailed test. It tells me alpha is 0.03, so that is meaning that the area here is 0.03. So that means that the area actually is 0.0300, because remember, in the areas for our standard normal distribution, those go out 4 decimal places, so we might want to write it with 4 decimal places. So when we look it up, we remember what we're trying to find. So we look on here, and we find the closest to 0.3000. We have 0.2981, and we have 0.3015. Oh, I'm looking for 0.03. I'm really bad at that. Okay, 0.03. Back on track. Here, 0.0294, 0.0301. So 0.0301 is the closest, so we'll use a z-score of negative 1.88. So this z-score is negative 1.88. Now, here's the thing. Let's say we were doing a problem and we found our standardized test statistic to be z equals negative 2.10. Then what I do is I place that z-score on this scale. Since it's a more negative number, it would be right in here. And since that's in the shaded region, I would reject h sub 0. But if instead, let's say my z-score was 1.32, that would be all the way over here, and then I would not reject h sub 0 because it's in the clear. If it's in the shaded region, we reject. If it's in the clear region, we do not reject. Okay, let's look at number 21. Right-tailed test. This area is alpha, which is 0.05, so 0.0500. Now, we can't look up 0.0500 because when we look up values, it's the side to the left, it's the shade to the left. So we're going to look up 1 minus 0.0500, so 0.9500. .95. It's in between these two exactly. So remember, when it's in between, when it's perfectly in between, we do the mean of the two. So it's going to be 1.645 is our z-score. So what kinds of numbers would we reject? We would reject any z-score that's bigger than 1.645. So the rejection region would be considered any z-score larger than 1.645. So I guess we didn't do that in number 19. So the rejection region here, it's shown as the shaded section, would be any z-score that's less than negative 1.88. 23. Now we have a two-tailed test. So in a two-tailed test, we've got some shaded region on both sides. And with alpha equals 0.02, we have to split that between the two tails. So the area here is 0.0100, and the area here is 0.0100. It's easiest to go ahead and look up the one that's on the left-hand side, and then just make it the positive one on the other end. So we're looking at 0.0100, 0. Gosh, I'm bad at this. I hope you guys are better than me. Oh, there we are. 0.0099, so negative 2.33. So this z-score is negative 2.33, and this z-score is positive 2.33. So our rejection region here would be any z-scores that are less than negative 2.33, and then also any z-scores that are bigger than positive 2.33. Let's go ahead and write out the steps formally for using the rejection region for a z-test for mu. Remember that this is when sigma is known. Step 1, we still have to verify that sigma is known, the sample is random, and either n is greater than or equal to 30 or the population is normally distributed. Step 2. identify H sub 0 and H sub A, and say which is the claim. Step 3, specify the level of significance which is alpha. Step 4, this is where it gets different from what we did before. You use alpha to determine critical values or critical value. There's only one if it's a left-tailed or right-tailed. There's two if it's a two-tailed. And we are going to sketch and shade the rejection region or regions if it's two-tailed. Step 5, find the standardized test statistic. Since we're looking for mu and sigma is known, that's the same we just used on the last one, which is z equals x bar minus mu, which is the claimed mu, divided by sigma over square root of n. Then we make our decision. So we're going to put that z-score on our rejection region graph, and if z is in the rejection region, which is the shaded region, then we reject H sub 0. If z is not in the shaded region, do not reject H sub 0. And then the last thing is always going to be to interpret the decision in the context of the original problem. And make sure that when you do that interpreting, you go back and use that box. Okay, we're going to do one example testing claims using rejection regions, and it is going to be from page 376. We're going to do number 37. We're going to follow all those steps we just wrote out. Basically, that's what the instructions say. So, a company that makes cola drinks states that the mean caffeine content per 12-ounce bottle of cola is 40 milligrams. You want to test this claim. During your test, you find that a random sample of 20 12-ounce bottles of cola has a mean caffeine content of 39.2 milligrams. Assume the population is normally distributed and the population standard deviation is 7.5 milligrams. At alpha equals 0.01, can you reject the company's claim? So our step 1 was to verify that sigma is known. Yes, they told us sigma is 7.5. We have to say the sample is random, a random sample, and population is normally distributed. And it tells us here, assume the population is normally distributed. So we're good on step 1. Step 2, we have to say what H sub 0 and H sub A are and identify the claim. So it tells us that the company states mean caffeine content is 40 milligrams. So that's telling us mu equals 40. So that will be our null hypothesis. Mu equals 40. It is the claim being made, which means our alternative hypothesis is mu is not equal to 40. Step 3, the level of significance. That's told to us in the problem. That is alpha, and it is 0.01. Step 4, use alpha to determine critical values. Sketch and shade the rejection region. So step 4, we're going to have a rejection region. Since it's a not equal to, that is going to make it a two-tailed test. And at alpha equals 0.01, each of these areas is going to be 0.01 divided by 2. So that makes it 0.005. And I'm going to tack another 0 on there so that when I look up my area, it has 4 decimal places. Then I'm going to figure out these two critical values using table 4. So I need 0.0500, which is halfway between 0.0495 and 0.0505. So I've got to find in between here, it's negative 1.645. Oh, I looked up the wrong number, 0.0050. Gosh, I wish you guys were here to help me. 0.0050, 0050. Oh, it's between these two. So between 0.578, 0.57 and 0.8. Oh my gosh. 2.57 and 2.58. So it's 2.575. And this one's 2.575. Next step, step 5, standardized test statistic. That was z equals x bar minus mu. X bar is our sample mean, and we tested 20 12-ounce bottles, found that the mean caffeine content was 39.2, so that's 39.2, minus mu. Mu is the claimed mean, which was 40, divided by sigma over square root of n. Sigma was 7.5 over square root of n. N was 20. So we've got 7.5 divided by square root of 20. And then I need 39.2 minus 40 divided by that number, and that gives me a z-score of negative 0.48. So I look at my critical values here, and I'm going to put negative 0.48 on there. Well, here is 0. Negative 0.48 would go right in there. Since it's in the clear, I do not reject. So my decision is do not reject. And it's always do not reject or reject H sub 0. So then step 7, that's the long one where we got to write out the little sentences based on that table. I do not reject H sub 0, and my claim was H sub 0. So I do not reject H sub 0, so I'm saying there's not enough evidence to reject the claim. So I've got to say at the 0.01 or 1% level of significance, there is not enough evidence to reject the company's claim. That the mean caffeine content is 40 milligrams per 12-ounce bottle of cola.